Label transition systems are used for many more purposes, and therefore there are many extensions of label transition systems. So in this lecture, I will shortly indicate 3 forms of extensions, such that you have an idea how they look like. There are different extensions to transition systems, and one of the extensions is the extensions with data. And that is an extension that we have already seen with the alternating bit protocol. So the idea is that with every action, we can simply tag a datum after it between brackets. So here we see get D, and that means we get a particular datum of a particular sort. So if the data is finite, and the data consists of datum 1 and datum 2, then we can draw the transition system, and typically a potential transition system that could describe the behavior of this system could be this one, where we actually read data 1 and then deliver data 1, or we can decide to read get data 2 and deliver data 2, and in both cases after delivery go to the initial state, get a next datum and deliver it again. Most important point is that you can add data to actions in this way, and so describe components that send data back and forth. An alternative extension is the extension with time. So there are many different forms in which time is added to transition systems. A very straightforward one is this, where you typically add a timestamp to an action. And we can describe this clock, and this clock ticks, and it ticks at time 1, and then at time 2, and then at time 3. And this goes on indefinitely. So this is an infinite transition system. One of the properties of describing slightly more realistic behavior is that it quickly can become complex. So assume that we have this clock, but it's not completely a stable clock. So it can tick at time 1, 2, or 3, etc. But it can also tick a little bit earlier, namely at time 0.9, or it can tick a little bit too late at time 1.1, and this can go on forever. So the typical behavior then becomes this. It can have 2 early ticks, and then the second tick is at time 1.8, or it can have 2 late ticks, or it can have any combinations of late and early ticks. And then this is typically the behavior that you get. So here it grows, and it grows even more. And this makes this field quite intriguing, because the understanding such complex behavior is often a quite difficult task. Another extension is an extension with probabilities. Currently this is heavily under investigation in the scientific community. And the idea is the following. We can have actions in the same way as we had before, but we can now also have probabilistic choices. And that's often denoted like this. So this means that you go, after doing the A with probability 1/2 to a state where you can do a B, with 1/3 to a state where you can do a C, and with 1/6 to a state where you can do a D. And this second choice is really a probabilistic choice in the sense of probability theory. So we have a very strange situation where we have non-deterministic choices that we cannot influence, and we have probabilistic choices that are governed by probabilities. So this is very weird behavior where you can non-deterministically go to a state with one distribution, or to a state with a different distribution. But these are typically the behaviors currently under study. Okay, so this was just a very short overview of the fact that label transition systems do not restrict to plain behavior, but that there are all kinds of extensions, especially with data, time, probabilities. And actually there are a few more, but I only mentioned the most relevant ones. Thank you for watching to this lecture. This is actually the last lecture of this first MOOC on labeled transition systems and behavioral equivalences. We have seen how we can model behavior and how we can reduce this behavior. But the big question is, of course, how can we actually model the behavior of realistic systems, realistic protocols, computer programs, distributed algorithms with automata. And for that, we need a slightly higher level process formalism, and that is what I will introduce in the next MOOC. So what I really hope is that I will see you again there, and that we can go through that together.